हे गाइस, कैसे हो आप सभी। उम्मीद करता हूँ सभी लोग मस्त रहोगे, मजे में रहोगे। और कल के लाइव स्ट्रीम में आपको कितना मजा आया, प्लीज आप कमेंट सेक्शन में लिख दीजिए। So yeah, let's get into the video series for our chat with your own chat GPT, build your own chat GPT series. So now that we have built an API which will help convert the documents into chunks and then store as an embeddings into the Chroma DB, next step is to build up a streaming UI and also a very good landing page so that users can, get attracted to the landing page. So in this video, we are going to start building the landing page and give the streaming UI response. But there is a catch over here. We won't be coding a single line. We will instead give it to Google Anti-Gravity and let it do the entire work. So the results may vary for each and every one of you based on the prompts that you give. Also, we'll be using PromptOS, my first product, to enhance the prompt and give us a better response. So without any further delay, let's get into the computer screen. So yeah, now that we have our backend API is ready, we have our server also port forwarded via nggrok and also running on 3000. So let me just do one thing. Let me just open up the Chrome here. Okay, and just let's go to localhost 3000. There won't be anything right here. And let me just also open PromptOS to enhance our prompts. Let's get this thing in action. Let's use PromptOS for all the working over here. So yeah, signing in. Until we sign in, let's first go there and let's go to prompt enhancer. Now I want to enhance the prompt, giving the prompt as you are an expert in creating landing pages, which also helps give a streaming UI to the user, just like how ChatGPT works. Your task is to help me create a landing page and also a slash chat page which will help give me a streaming response and make sure the user experience is very good and is the main thing which is focused on. So your task is to help me create a landing page and a chat page. The project that I am creating is a second brain project, which is like a custom chat GPT built on top of my custom knowledge base. Okay, so this is the prompt that we will be giving. Okay, let PromptOS do its work and let the PromptOS enhance the entire prompt and give us a better, good looking, bigger prompt. So it's currently enhancing the entire prompt that I have given. Yeah. So you can see the prompt of 5 to 6 lines is now converted into almost like 20, 30 lines of prompt. So what is the difference? You are a world-class UX UI design architect, product strategist with deep expertise in crafting highly engaging, intuitive digital experiences. It has given everything. What should be the overall UI UX principles, error handling, and everything. So I'll just copy this and then let's go to Google Anti-Gravity, paste the entire thing. Okay, and we'll be using Claude Opus 4.5 only for thinking. And yeah, let's get it working. Let's see what exactly the agent looks and thinks here. The user is asking for a comprehensive UX UI design. Let me just read, bro. Uh, yeah, for their second brain project, this is a detailed design strategy request, not a code implementation task. They want to conceptualize design for landing page, chat interface, and everything. It is a substantial request and requires full planning and documentation. Yeah, this is where the agent is now creating an artifact. It will create a task.md file, which will basically consist of all the tasks that it needs to perform. Once the user gives an approval that like, okay, this is the task you can perform, you can go ahead with it. It will start creating all the files that is needed. So it is analyzing the entire code base structure. It analyzed the main landing page based on TSX, and then it also analyzed the global.css files that we have, and now it's creating a UI UX design blueprint. So let's wait on it on how much time it takes to execute the entire task. Now that we have two files created here, one is the task explore existing code base structure. This is what is the task that the agent takes for itself. It explored the existing code base, reviewed the current implementation, and created a blueprint. Now this is the blueprint it created. Wow, it's actually working as a product designer or product manager, because this is a summary. Second brain, what is the value proposition, landing page, trust building, conversion, personalization, everything. So the primary message that is given here for landing page, your message instantly accessible, your AI personally trained. This is the page structure it is giving. Okay, there are a lot of things. It has actually, created a PRD, which is a product requirement document. And damn, this is really good. So now I'll just tell it, please proceed with the implementation of the UI and make sure there is proper error handling done. Use the Google Gemini as LLM to make the chat work. Okay. Now let's see what the agent has to do. I'll just close this task. I'll just open this and remove everything over here. There are some things that it is currently exploring. It is exploring the package.json file, the entire layout, then also analyzing the route, the backend API route. Allow file access .env. Do I want the .env access? Let's say allow only once. I don't want to allow it more. I'll allow only once. And it is looking into the public folder if there are any images available or not. Now it's working on generating all the required files and creating the UI. It's now creating an implementation plan document as far as the way it had created for the UX blueprint. It's now doing a verification plan, manual browser testing, testing the landing page, verifying the hero section and everything. What I'll do is I'll just say proceed with the working. So now based on this task list that it has created, the plan that it has created, it will now go on doing one by one, adding things one by one. So there are a lot of things that it will create: UI button, input, card, a loading signal, chat session page, chat sidebar, chat message, chat input, streaming indicator, everything A to Z. What developers usually had to create it by themselves. Now it is done entirely by AI, planning, plotting, and then also, coding the thing. Now, as you can see, it has started modifying everything. Okay. And let's have our Chrome tab here so that we will have the changes live on the site. Okay. I'll just close this, and this. It has created some utils, which is basically to format the date, format the time, also generate a unique ID or debound. See here, it is also taking care of the rate limiting for APIs. This is what I have not told it. I have not told the LLM or the agent to use the debounce function or debounce logic, but it has itself created the debounce function. Copy text to clipboard, sleep utility and everything. It has now started creating the UI components. This is a button component that it is creating, which is also implemented with the is loading logic. Okay, it has completed creating all the required components. Okay, this is an input component. It has created card. Okay, that is good. Loading button, global CSS. Good. We need to see the final output wherein it has all the main landing page and the slash chat page. Currently, if you go over here, you will not see anything because it's only the components that are created. The page is still in progress. Okay, so we'll just wait for the LLM to complete generating the page.tsx and also the slash chat.tsx. Now for the building the landing page, it is also creating another task for itself, and now it has started working. Page.tsx. Okay, see, this is the power of AI, wherein giving it a very good prompt, giving it a very fine-tuned prompt on what exactly the AI has to do. This is the kind of output that you get from an AI. Usually, if a developer starts writing this code, it would take him around 1.5, 2 or 3 hours to make this working along with the animations, the color scheme, and everything. Wherein, with the help of AI, your task is done in within literally a minute or less than a minute with all the animations. So it has completed the page.tsx. Let me see if it has slash chat. Okay, the route is given, but currently it is not working on slash chat. No worries. It is now creating a chat API route with Gemini and ChromaDB RAG. Okay, that's good. Now that we have the ingest API ready, it has also started creating the chat API route. Now let me help you understand how the route would work. Now what happens is, let me just first go to XRL draw. Now what happens is you have your data. Okay, I'll just increase the font here. This is your data, and this is you, the user. Now you want to get the data from your database to the user, and you want the data to be very in the form of natural language. So that is where you use LLMs. This LLM can be anything that you want to use. Either you can go with OpenAI, you can go with Gemini, any LLM that you would like to use. So that is where this LLM would come into picture, helping you interact with your data. Okay, so here what we have to do is we'll have to create a Gemini API. So, okay, we'll just go to aistudio.google.com. Obviously, you need to create an account. Here on the bottom left corner, if you see, we have an option of get API keys. So what we'll do is create an API key, Gemini API key. No, not for the main website. I'll create a project. I'll rename the project as Second Brain YouTube. Okay, I'll create a project, and then once the project is created, we'll get the API key and create the key. Okay. Earlier, what would happen is you'll have to go to Google Cloud Console and then create a project and get the API key from there. But now we have everything right on this UI. So we'll copy the API key. We'll go to .env and we'll just say Google Gemini key equal to this key. Okay. And okay, this is the name of Gemini API key. Gemini, we'll have Gemini API underscore key. Okay. Now let's see if we have the chat page ready. Yes, we also have the chat page ready. Over the side, you can see this is how Google Anti-Gravity is actually testing the product that it has created. This is not what I am doing. This is what Google Anti-Gravity is performing. If you want, you can just check here. Clicking start chatting in the navigator bar to chat the page, capturing initial state, and doing the chatting part. And this is, I think it has created a chat session. Okay. So let me just test it. If everything works fine, I'll just open the inspect page here in the console and start a new conversation. Is this working? No, this is not working because there are some undefined properties in chat input. Okay. So after getting the system prompt, there are some things that now we will have to code. So let's start with it. We'll have to create a function which will extract the user's message text. Okay. So it will pass message as an any with a string, and if we will have if it is an array, then message dot parts, return the message parts, msg dot parts dot map, wherein we will have a variable p of type any, and with which it will match if the p type is equal to text. Okay, or if it is equal to text, then keep it as it is or have as an empty string. Okay, then we have to join with a \n and then trim it to remove all the spaces that are present, and then we'll have a blank string which is returned if there is nothing else present. And we'll also define the collection name here, so we'll have const collection underscore name equal to second break. Okay, so this is the function that we have created right now. I'll just format the document. Okay, this is the first thing done. Now the next thing is to now start creating a post request. Export async function post. Okay, obviously inside a try catch block. The first thing that we will be doing here is we will be importing the messages as an await in the form of request.json. We'll update this request as req request.json as messages. We are typecasting it here because we are using the UI message from Vercel AI SDK. Okay, conversion to type may be a mistake because neither of type sufficiently overlaps with other. If this was intentional, convert the expression into unknown first. Okay, we will look into it afterwards. We will have to keep this and have it over here, and the JSON would be a function. Okay, now the error is gone. Okay, now that we have this, there would obviously be a condition to check if there are any messages present or not. If there are no messages, or if there is no message dot length, then what we have to do, we will just have to return a new response that no message is provided with a 404 status. Now we will have to get the last user message as query. Okay, what will happen is, now if you see right on this side, the latest message that I will give here would be taken as a query. Okay, the above messages would be kept as it is, but the latest message that I give would be taken as the query. This is the same logic that will be applying over here. So what I'll say here is const last user index, take it from the messages. Okay, first do one thing, first reverse it. Okay, and then find the index where the role is user. Okay, I'll just do this. Next thing, for now I don't need this and this. Now that I get the index, I'll now check if the last user index is -1, then say there is no user message found. If there is no any message given, then there is no user message found. Now we'll have to create a real index. Const real index equal to messages dot length -1 minus last user index, and then we will take the last user message from the messages. So it would be messages of the first real index that we get. Now we have to form a query which will be extracted from the function that we have created over here. Okay, it would be last user message. Next, there are some basic things that we have to perform. If there is no query, then we'll just say no queries provided. Now is the part where we are doing the RAG, which is retrieval of top k chunks from chroma. Okay, so now let's understand what are the top k chunks. For each of the document that is stored in the DB, there is an embedding that is created. Okay, let's copy this embedding and let's see how long is this embedding present. Oh, this is pretty big embedding. Okay, this is for our first document. Now if you see, there are, the embedding starts from 0.012776517 and ends at -0.05. So what happens here is to find top k chunks. What does it mean? That there are these embeddings are in a plane. These are in a XYZ plane. And let's say there is one embedding present here, one present here, one present here, one present here, present here, 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 here. This dots or these embeddings or values can be for anything. Okay. Now, if we see here, we have the numbers right here. These are not the numbers for each of the statements. These are the numbers for each of the characters. Okay. So what getting the top k elements means, whenever there is a user query, given, what the LLM will do or what this function will do, it will find out the top k meaning top 5 or top 10 elements near to the query embedding. Okay, so that we can get a better or we can get a very accurate response. Okay, so let's get here and let's now start writing the logic for it to retrieve the top key chunks from chroma. So we'll have const collection equal to await get or create collection with the collection name. Okay, const rag results equal to await collection dot query. Now we are querying it from ChromaDB, where the query texts are the text from the input that we are taking. What are the end results that I want? What are the similar results that I want? I'll have the end results as 5. Give me the 5 nearest chunks from it. And then also include, there is something that I want it to include, is include the documents and also include the metadatas. Okay, nothing else. Don't include the distances as of now. This is the reg query that we have performed. We have tried to get the top k chunks, top 5 chunks from chroma. Now, what we'll do is const docs rag results dot documents and get the document at the first index if present, or give it as an empty array, which will be in the form of an array of string, and also get the metas as from the docs from metas question mark at 0, same as what we are getting for the docs, and this will be in the form of a record. The first would be a string and the second type would be an any. Now what we are going to do is we are trying to build up a context block. Now what is the context block? Usually LLMs don't understand what the user actually has to offer. Now whenever we are retrieving it from the ChromaDB, we have to eventually give or build a context block for the project. Okay, so what we will do here is we will have const context equal to docs. Okay, docs dot map. The first thing would be doc, second thing would be an index, and get some things from the doc. The first would be meta, which will be metas of the index or as an empty object. The second thing would be the source, const source equal to meta dot file path if present, or meta dot path, or if none of them are present, give it as an unknown. Okay, the next thing is to find out the chunk index. So meta dot chunk index, or this index that we are mapping with, and then what we do is we say return the source value I, it would be I plus 1, along with the file source and also the chunk as the chunk index \n with the doc, and then join it via new lines. Okay, this is basically the context block that we have created to give it to the LLM. Now this is where our system prompt would come into picture. Now what we will do is firstly go to the system prompt and then we will just trim it. Okay, so those who don't understand what trimming is basically it's removing up the empty spaces, remove the leading and trailing white space. Okay, so after having the context block, we will have const augmented end user, which will be typecasted to UI message, and then it will pass the ID as last user message dot ID. Second would be the role as the user and the parts. Okay, the first part would be the type. Type would be in the form of a text. What would be the text? The text would be the query, which will be along with the context from your knowledge base. Okay, it will be like if there is no context found, we will just say no matching context found. Okay, and then we will say, okay, I end this and say now answer the user's question strictly based on the context above. Okay, so I think I'll have to end this right here. Okay, format it once. So what happens is whenever we are giving any question to the LLM will have the context, the entire context from the source of and the file and the chunk given to the LLM, and then LLM will do the processing and then give us a response. So now we have the augmented user ready. Now what we will do is build a model message, okay, which will be basically system plus previous history plus the augmented user message. So here we will have it as, let's say we'll rename it as user UI messages with context in the form of UI message. And what we'll do is we'll return the role as system, obviously. And let's say we'll have the ID also. I will keep the ID as system -1, the role as system, the part, the type would be text, and the text would be given as system prompt. Okay, and the messages then will be sliced and then returned to the user. Now after this we'll just give a stream response. So we will have const result equal to stream text. The model that we'll be using here is Google, and let's say we will use the Gemini 2.5 Flash, which is the current version that we have. Okay, and then the messages will be passed as convert to model messages with UI messages context as the value. Okay, this is what we are taking from the B0 AI SDK. Okay, we don't need this. Okay, after that we will just say return the response. So we will say return result, not real index, result dot to UI message stream response. Okay, so yeah, this was a complete code that we had to write, but no worries, we have this chat ready. So let's go over there and let's go here, start a conversation. Okay, it's trying to create the chat history or chat this. So what I'll do is I'll go to the chat page, page.tsx. I don't want to go to create the slash chat session. So let me do one thing, I'll just change it here and give plots on it. Remove creating the chat session for when clicking on start chatting. Okay, I don't want that for now. Okay, this also model has reached. Let me go with Gemini 3.5 Flash. Hopefully it should work. So for now we don't need. to have the sessions. In the further videos, obviously, we will start also implement that thing. But for this video, we don't need it. So it thought the entire thing. Now it's doing the changes that is needed. It analyzed this page, and then it will do the modifications. It also analyzed the main chat page. Let it do the modifications as we wanted. Now it has started modifying the changes. As we see here, there are a lot of changes done. Removing the dynamic session route. Okay, please remove this part. So now this is deleted, and I'll accept the changes here. There are still some errors. It is looking into the errors, lint errors, and then working on it to get the errors resolved. Let's wait for that to get completed. But yeah, one thing that I have to say is, after Google Anti-Gravity has come into the picture, a lot of things have become easier for me as a developer, for anyone, any student who is building their project, because that gives you the ability to create stunning UIs, which were earlier only just on the Figma design, and it takes a huge amount of work and effort and time for developers to build that thing. That is where Google Anti-Gravity saves a lot of your time and makes things better. So yeah, yes, accept the changes. There is some more linting errors as we see. Set input, handle submit. Okay, please work on it. Please change it. So now it went again into its own browser to test the features. Open the browser. Wait for 2 seconds. It's testing it again. There are some properties that it cannot find. Undefined chat.trim, value.trim. So it's now basically clicking a picture of its browser, and then giving again into the chat, again into the LLM, and then doing the feedback purpose. Know the solution for this. I'll just stop this. What I'll do is, there are some things that we need here. We'll have to go through the documentation of the Zero Vercel AI SDK. Okay, so let's go there. And there is some streaming option given here, streaming UI that we want. So what we'll do is, we will have to make the API call using the function as default. There is also function named default chat export, something like that. Default chat export or default chat transport. This was a function. So what happens is, we have to give a transport function here, and I think here it's not present. So what we'll do is, we need messages. Don't need this. We need messages. We need send message, and also we need the status. Okay. We don't need error, stop, nothing. And after use chat, what we are going to do is, we'll have this removed, and we will have a transport wherein we will define a new default chat transport, and there we will pass the API path. It will be /API/chat. Okay. And regarding the input, what we'll be doing is, we will have a variable here, const input and set input, as a empty string. Okay. Now, after this is done, we'll have to go over to the logic, wherein it is doing, like, sending the value to the LLM. Okay. So there should be a button right here. No, not this. Input area, chat input. Okay, this is the chat input function, and handle submit. Okay, in handle submit, we have an event which will give on submit and change the value here. Okay, so what we will do here, we will change the handle submit function here, and then we will say, first of all, make it as an async function, which is of the type react.form event. First thing, obviously, e.prevent default, and then if there is no input.trim, we will just return. Okay, or else we will await send message in the form of send message in the form of text as an input. Okay, and then we will set input as an empty string. Okay, so we'll just do one thing. We will copy the set input from here and add it over here. We need to also get the use state here. Okay, we have the set input ready, and to get the send message, what we will do here is we will also get these things from here to here. We will add it over here. Default chat transport import, and this is also to be imported. Okay, I think now there are some other issues as well. I will not go through all those issues. I'll just say, please fix the issues related to chat page and chat input. Okay, let me till then let me just check if things are working fine. I'll just go to localhost / chat. Okay, there are still some issues. Okay, it's looking into the issues and fixing it. Let's wait for it to fix. I'll just till then I'll close everything here. /app route task is also closed. Chat message is also closed. Yeah, it's working on this. I'll do one thing rather than going here doing everything. I'll already have a chat page ready. I'll just replace everything with that. It's not more of a complex kind of a structure, but rather a simple way to get the chat done. And for that we have to create a component which will be inside app components, and the component name is typing indicator.tsx. Okay, we'll just create the component right here. Okay, from @. Okay, now that we have this ready, we will just say, what do you know from say machine learning? What do you know from machine learning? And I'll just click on send. Okay, we have a typing indicator that is working to give us the response. Let us check here that okay, there is an API call that is made. There are some issues here. You have exceeded your current quota. Please check your plan. Okay, we seems like we have some issues here. Okay, let me just refresh it. How come we have used our quota? I think there is some other LLM that is getting used here. Let me see. Model Gemini 2.0. I don't want to use 2.0. I want to use 2.5. So is it taking okay? Reject. I want to use 2.5. I don't want to use 2.0. So let me just ask the question again. What do you know about, sorry, not this. What do you know about machine learning? Okay, and I'll just send it. Let us wait. Are we getting a response? Yes. Yes, guys, we actually are getting a response which is from our knowledge base. Hello there. I can definitely tell you what I know about machine learning from your knowledge base. It looks like you have some great notes on the topic. And if you see here, it is also doing the citations. It is from getting from the knowledge / sample notes.md, which is from chunk 0, chunk 1, chunk 2 as well. So yeah, this is how you are creating a streaming response. So yeah, this is something, actually this is something crazy. Getting a completely custom based chat GPT for your own project, for your own knowledge base. Also getting the citations, like from which node the current response is taken from, which source the current response is taken from. Getting to understand that kind of thing is something really crazy and really, deep, and I'm literally fanatic about understanding these kinds of concepts. So yeah, we finally have a streaming UI for our project. Obviously, there are some more things that we'll be implementing in the future videos. What we are going to do is just like ChatGPT, how ChatGPT stores data for each session. We will be creating sessions for each of the data or for each of the user that is coming here, and for that we will be using MongoDB. So yeah, I think this was a long video, but it was a fun video understanding how these rack system works. How do you give up a context to your LLM? How do you get the response in a streaming manner from your LLM? So yeah, let me know your thoughts on this video in the comment sections given below. And yeah, see you guys in the next one. Until then, bye bye.